Okay. We also did the flow experiment. And when we did that, we got 3 data points. We got 3 simultaneous linear equations using the form y equals at squared plus bt plus c of a quadratic function. We solve for a, b, and c. We rewrote the form to get depth as a function of t. Then we answered questions about it. We solved f of t equals c, which corresponds, of course, on the graph. Quadratic function, so the graph is a parabola, but for the flow experiment, it stops at the vertex, right? Once the water's done flowing out, it doesn't start back in, okay? And if we got C here, there's our picture for how we solve a function equal to a constant. Because the value of the function is a y value, the way we graph things by default. So you find the y value that you want the function to equal, and then you find what x or t value gives you that y value just by projecting. Something we know how to do. Hopefully you have totally incorporated that idea, because you've got to be able to use it. It's an important idea, okay? Or we could solve I say find f of c. That means we find c out here. We go up here and there's f of c. Other things we do with our quadratic model. The fundamental triangle for a t interval gives us the average rate of change of f, or let's say of y, with respect to t on that interval. This is because the rise is the change in y. Run is the change in x. Actually, in this case, it's a change in t, so we'll keep the variable as t. Okay, rise is change in y, run is change in t. An average rate of change of y with respect to t is the change in y divided by the associated change in t. That's what an average rate of change is. If you make $50 in 4 hours, the average rate at which your wealth is changing is $50 divided by 4 hours, $12.50 per hour. Make sense? That's easy to understand. Now, other rates of change can get kind of weird to conceptualize, but the average rate of change of this one, well, y is depth, t is time. This is the average rate of change of depth with respect to time. There's an interpretation. We need to be able to interpret these things, and we're going to do a little more work with that. Ask you to do some more problems with that. With the idea of interpretation, you've already done a number, but we want to get really good at it, because that's maybe the biggest thing that's going to be to your advantage in your future education. Okay. Now, rate of change in the interval t plus h is what? It's f of t plus h minus f of t divided by h, because f of t plus h, in this case, would be your depth at t plus h. T plus h is a little later than t. Maybe a lot later. We didn't say h was small, but usually we think of it as small. So t is some time, t plus h is some later time. If we subtract the depth f of t from the depth f of t plus h, that's how much the depth changes. And how much does t change? Well, t plus h changes by h. If you start at t and change by h, you get f of t plus h. So here's your change in t, right? That's your change in y divided by your change in t. That's your average rate of change. And I should have said average rate of change. Instantaneous rate of change is the limit as h goes to 0 of f of t plus h minus f of t over h. We've done a number of problems with that, with quadratics. Okay? At least they've been assigned, and many of you have done it. So it's something you want to be able to do. Not particularly difficult for quadratic. It's really pretty simple. But you got to be able to plug in the t plus h into your, where to go, at squared plus bt plus c. Where do you see that there? Right? Replace t by t plus h. And you get this. And then just write this down, and you get f of t. You subtract them, and a lot of stuff goes away, and a lot of stuff is left. And what's left, every term will contain an h, so you can divide the h into that. Okay? Now that's an overview of something you've done. I'm reminding you today is the day when I remind you of things that we've done and show you how they fit together. Okay? So you might not remember every detail of it, but if you think about it, if you've done it, then you should be pretty well equipped to review it and do it on the exam. Okay? So, flow experiment told us all this and more, because we got into the properties of quadratic functions. the vertex of this parabola. How do we get the vertex? And what's the significance of the vertex? Well, that's the depth and the time at which the flow stops. Okay? It's not going down anymore, it's done. Okay? And there's more to it that I'm not going to mention yet. But we do get an axis of symmetry, which is negative b over 2a, right? Whatever the numbers are here, you know how to do that. Y'all are pretty good at that if you review. Okay? Some people did pretty well on the midterm. I think you're going to be pretty good with it. Okay, so we can find the vertex of this thing. Tells us something about at least our model of what's going on in that container. So there we have that. And, you know, again, you got to know the properties of quadratic functions. You got to know how to find the vertex and all that stuff. As I said, I think you're pretty good at that.